Essentially, the James Webb Telescope has revealed the clearest picture of Proxima B in history, offering breathtaking insights into a possibly habitable exoplanet. It supports us as we embark on a journey through space to uncover the secrets of Proxima B and determine if it might be the next Earth. We ought to take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star. This planet is more than just any ordinary rock. It's real. See. Proxima B is found a mere 4.2 light-years from us. This planet is covered in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Wait, there's more. Proxima Centauri B isn't alone in that system. Around the red dwarf star, it has a companion, Proxima Centauri C, and who knows what other mysteries the star system holds. Maybe there's another companion we haven't found yet. The secrets don't stop there. Proxima Centauri produces roughly the same amount of energy for its planet as our Sun does for Earth. Could this truly mean there's water on its surface and perhaps even life? As we explore beyond our own solar system, we encounter a new universe of exoplanets, planets that orbit stars other than the Sun, with 200 billion stars in the universe. The opportunities for exoplanets are endless. Some even wander freely, untethered to any star, like lone travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. It has a year that lasts only 112 Earth's days and orbits its star at a distance generally closer than Earth is to the Sun. One side of the planet is constantly washed in sunlight, while the opposite side remains in everlasting darkness. Let's look at Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is the alpha component of the Centauri triple star system. This system includes Rigel, also known as Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. These stars form the closest star system to our solar system. Rigel and Alpha Centauri B form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity under 2.7 Proxima Centauri, also called Alpha Centauri C, is a red dwarf M-type star. It lies roughly 4.2 light-years from Earth, closer than the other two stars, typically about 4 times the distance between Earth and the Sun. In fact, Proxima means the closest in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13. It's much fainter than the human eye's limit of 6.5. Still, don't let that fool you. Proxima Centauri is a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient stars in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it experiences frequent and intense explosions. As a low-mass star, its habitable zone is much closer than the Sun's. It's projected to be somewhere between 0.023 and 0.054. Oh, but it's not as habitable as it might seem. Proxima B is bombarded by intense ultraviolet radiation from its star, radiation stronger than what we receive from the Sun. It's so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, something essential for regulating temperature and maintaining a water-friendly surface. Without it, living creatures would be vulnerable to harsh space weather, making life nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is far from capable of supporting life. Scientists remain cautious, as many factors may render it hostile. Still, the mission to uncover the truth about Proxima B continues. And some hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, it was finally launched in 2021 and now supports our efforts to determine whether life exists on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light and can capture images of a planet's surface glow, searching for patterns that could confirm the presence of water or an atmosphere. But what if the atmosphere isn't conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus with a thick atmosphere that's significantly denser than Earth's, and extreme temperatures that would make life impossible. Unraveling the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space scientists are feeling the pressure to find new ways to observe planets. Like Proxima B, much is at stake, but the rewards are even greater. The chance to investigate the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit? It's the closest exoplanet to us, which makes it particularly intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could, indeed, have conditions suitable for life. Proxima B's proximity makes it an ideal target in our quest to find life beyond Earth. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar. For future missions, as technology advances, it remains one of the most exciting endeavors in space exploration. However, it's no easy task. A spacecraft similar to Voyager 2 would take 75,000 years to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could propel vehicles traveling to the Alpha Centauri system and Proxima along with it. This technology uses solar radiation pressure to keep spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler: this cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like any ambitious mission, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee life. Proxima B's atmosphere could be like Venus, thick, hot, and inhospitable. Furthermore, the James Webb Telescope can detect such emissions if the planet reaches sufficient brightness. Only 5% of the daytime side now. 5% may not seem like much. But when dealing with a star that's generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may use bright orbital reflection mirrors to reflect sunlight from the daytime side to the side at night. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? Type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Names have been given to some of these massive superjupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiter's gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close, with its furious storms and extreme heat. In addition to gas giants, Neptunian giants are also found exoplanets that are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres making them hard to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating and recent discoveries of exoplanets is the one orbiting Proxima Centauri, named Proxima Centauri B. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. It orbits in the habitable zone of its host star, and scientists are currently investigating whether it could be capable of supporting life. Proxima Centauri B is of particular interest because it is the closest potentially habitable planet to our own solar system. As we continue to explore these fascinating worlds, the James Webb Space Telescope promises to provide even more insight into their potential for life, and habitability. The allure of Proxima Centauri lies not only in its proximity but also in the enticing possibility that it may harbor conditions conducive to life. As we investigate the exoplanet's characteristics, the question on every scientist's mind is whether Proxima holds the key to understanding whether life can exist beyond Earth. While it may be a rocky world, its orbital position within the habitable zone and its potential for water presence make it an exciting target for future exploration. However, there's a catch. The proximity of Proxima Centauri B to its star means that it could be subject to dangerous radiation, especially given that red dwarf stars like Proxima Centauri are known for their violent flares. These flares, which emit intense bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to take root. Proxima may also face tidal locking up, situation in which one side of the planet is permanently facing the star while the other side remains in darkness. This could lead to extreme temperature differences between the two sides, complicating the conditions needed to support life. Yet there are still many uncertainties. We do not fully understand how the atmosphere of the planet interacts with its environment. For example, could Proxima B possess a protective magnetic field that could shield it from the star's radiation? This would be crucial for ensuring the planet's survival. Similarly, the possibility that life, if it exists on Proxima B, could have adapted to the harsh environment cannot be ruled out. Life on Earth, after all, has succeeded even in the most extreme conditions, from the depths of the ocean to the frozen tundra. Could Proxima offer a different type of life, one that thrives in the face of challenges we cannot yet imagine? In addition to these considerations, Proxima B's proximity to Earth makes it a prime candidate for interstellar travel, especially with future advancements in space technology. While our current spacecraft, like Voyager 2, would take tens of thousands of years to reach the system, more ambitious projects are being proposed. Solar sail technology, for example, suggests a possible solution. Using the pressure exerted by sunlight, solar sails could propel spacecraft at a significant fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore distant exoplanets like Proxima Centauri B. The potential to one day send humans to Proxima B is an even more enticing possibility. While this prospect remains far off, fuels our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima's atmosphere, study its surface, and gather essential data to help us determine whether it can support life. Through its infrared capabilities, Webb can provide us with invaluable insight into the weather patterns, composition, and more, bringing us closer to understanding whether Proxima B could one day be a second home for humanity. As we move forward, it's clear that exploring exoplanets like Proxima B offers more than just the chance to find alien life. It also represents our desire to understand the universe and our place within it. Each discovery, each piece of the puzzle, brings us one step closer to answering fundamental questions about life, the cosmos, and what the future holds for humanity. Whether Proxima B proves to be habitable or not, the journey of exploration will continue to inspire and shape our future.